So the part of point of this is that it just sort of magically works. So if you're curious about all the gory details, we can have some fun conversation over the beer. So in that way, you can provide you can have a pretty large number of machines that have the bare bone operating system installed. So the next step is that Hudson needs to be able to talk to these machines that you just installed, right? So the way the Hudson does that is by using the master-slave architecture. So the master is the one that sits in the middle. This is the most important things, and then that's the one that serves all the HTTP requests. So when all the HTML UIs that I showed you earlier came from master. And this is also the node that stores all the important information like your project configurations or your build records. And this is generally the node that needs some of your attention, like backing up and disaster recovery, that kind of things. And then there are slaves. You can have lots of slaves, and then each slave, therefore, is designed to be very simple to deploy. So it only needs a 170 kilobyte jar file on that machine. And then slaves are also assumed to be reliable, the unreliable, meaning while the cluster is in operation, you can add or remove slaves. And as you can imagine, once you start having a fairly large number of machines, some of them will always have some kind of problems, right? So this is very important to sort of make this whole thing work. And then at least we know that there are production users that's deploying this at the scale of like hundreds of the slave nodes. The interesting thing that seems to happen that I noticed is that once it grows beyond certain size, let's say if you have a Hudson cluster of 100 machines, that's a pretty big cluster. That means you have a lot of workloads going on in this cluster, which in turn means you probably have a very decent sized team that can generate that kind of load. And then when your team gets bigger, they start to develop slightly conflicting goals. So what used to happen, again, also in Sun, is that the one team is like right before their release deadline. So they really want a stable Hudson. They don't want any change in the deployment. On the other hand, there's another team that's in this bug hunt drive, and they want to install the find bugs plugin so that they can see the find bug report on Hudson. So they have this conflicting goal that, well, one guy wants to install a new plugin, another guy just couldn't afford to have any potential destabilization. So eventually what happens is that they decide to each own a Hudson instance to themselves. And so therefore, these 100 nodes get split into 50-50 and so on. So because of these organizational reasons, there seems to be natural upper bound in the size of a cluster. And that right now, that seems to be around 100 nodes. So anyway, so the bottom line is this architecture is written in a way that scales reasonably well. And then the master and slaves needs to communicate with each other. So the way this is done is by having a single bidirectional byte stream between them. So, and we don't need any shared file system or that kind of setup or the TCP/IP direct reachability. So often people have the crazy network requirements. Like in some of the defense companies, they just cannot have any unencrypted traffic on the network, period. So they have to tunnel every connection over the SSH or some other means. And then, there are firewall, occasionally there are firewall in place between different nodes, like different geography. So having this flexible connectivity in Hudson would allow it to be deployed in many different environments. So that's the lower level stuff, but it's still not easy enough. Yeah, so because you have to start some process on the slave, and then that has to talk to the Hudson master, right? It's not a rocket science again, but it's tedious. And tedious is being tedious is our enemy. So in Hudson, we implemented the additional support for the SSH. That is, if your slaves are Unix, that's released in the past 10 years, then it will come with the SSH daemon, right? So the Hudson has a built-in SSH daemon, the SSH protocol implementation in it, so that it can talk to the remote slave node through the SSH, copy the necessary binary over the remote. And if the Java is not installed, it's even capable of installing Java on this node. And then it will start the slave there, and then things start to function from that. So in this in this environment, all you need to specify is just a host name and the username that Hudson is going to log in. And then if you hopefully you have a reasonable public key authentication structure set up, so you don't have to manually specify the password to log in. But if you do need to specify password, you can also do so. And in this way, Hudson master can connect to the Unix slaves without you ever going to Unix slaves and do something on their console. So for Windows, you can make SSH demo running in there, but it's again it's a bit tedious because you have to install Cygwin or some kind of things like that, and that takes a bit more work. So Hudson has a DCOM implementation. The DCOM is the Windows speak for doing remote management and other things. So Hudson can also start a slave through DCOM to the remote Windows node and copy all the relevant files, again install the JDK if necessary, do the whole thing. So the end user experience, even though the underlying implementation is drastically different, the end user experience is the same, that you just specify the host name and then you specify the username and password to log into this Windows remotely. And then the Hudson will be able to sort of spread its tentacles and start using that machine as a slave. So again, you can install, as long as you got the Windows installed, you don't even have to go to that Windows node to start a slave. You can do all these things just from Hudson's central UI. So that pretty much covers the situations, all the major machines. But the only downside between those previous two arrangements is that the master needs to be able to see slaves because it's the master who's initiating connections. So if all your machines are in the same network, that have direct reachability, then good. But let's say if your master and slave is separated by some kind of firewall that prevents master from seeing the slave. So let's say maybe you have a Hudson master outside your firewall, but because putting machines outside your corporate firewall is kind of expensive, you might have more slaves that's inside your network. So in those environments, the master outside the firewall just cannot get into the slaves to initiate the connection. So there's a separate mode available to do the connection the other way around. You could have the slaves initiate the connection to the master, and then you can do so by the Java web start. So you could, if you're doing this, you do have to come to in front of the display of the slave machines, but from there you can access the Hudson UI, and if you click this launch button, then that will bring in all the necessary files, start the program, make a connection, and then it starts working. So this does require someone clicking mouse and doing things, but once you start it, it gives you an option to install the slave as a Windows service. So if you choose this menu and confirm your intention of installing a service, then you could, from then on, the slave agent is installed as a Windows service. So even if you reboot the machine, it will automatically come up and initiate the connection to the master, and everything will work. Now, on Unix, well, there's no nice UI support like that, unfortunately, but you could still make things work by executing this command. So it will need a little bit of etc in the script hacking, but in this way, you could still have a Unix slave that's initiating the connection to the master. So finally, in this way, we have a functioning cluster where the Hudson does have control over all these machines. And then, so the next thing that we identified as a tedious problem is installing build tools. Because often, well, so certainly in context of Java, that the testing often needs to be run against a very specific version of the JDK or the JRE that you're certifying your project with. So if you're doing that and then you have a larger number of machines, you have to install this environment everywhere. And if it's a homogeneous cluster, that is, let's say if everything is Debian or if everything is the Red Hat, then there are tools that make this kind of work very well. But if your cluster consists of part Unix, part Mac, and part Windows, there's really no tool that helps you with deploying all the tools in the right place. So Hudson started to do that. You could now install the JDK from java.sun.com automatically. And Hudson will, depending on where it's installing, Hudson will choose the right bundle, go through all the click-through that the Sun put, well, Oracle puts, and then it will download the JDK and it will install it into the right place. So you really don't have to do any configuration on the slave. You could just let Hudson take care of all these things for you.